This is lesson 3.2, truth tables and equivalent statements. The objectives are we're going to find the truth value of a conjunction, find the truth value of a disjunction, conjunction meaning and, meaning both, disjunction meaning or. Find the truth values of compound mathematical statements, construct the truth tables. For compound statements, understand, determine equivalence of statements. In other words, two statements that are equal. And we're going to touch on the De Morgan's law a little bit. All righty. Okay. The truth values of compound statements are used to find truth values. Okay, so basically we're going to be working with truth tables. Truth values of conjunction P and Q, symbolized with P and then this rooftop looking symbol Q, are given in the truth table and implies that both have to be true. So with statements that are P and Q, both P and Q must be true. For P and Q to be true. Okay? All right, so let's see what that looks like on the truth table. All right, back up. Okay, so you're always going to start off with the left side being P is true, Q is true, and then P is true, Q is false, and then P is false, and Q is true, and P is false, and Q is false. Okay, so basically they're looking at every possibility of how the combinations of P and Q either being true or false. So in order for P and Q to be true, both have to be true. True and true. Okay? So in other words, let's say you are going to a party. Okay? And you're going to the party and your girlfriend's going to the party. Okay? Or boyfriend, your friend. Okay? And you're saying here that I'm going to the party. It's true that I'm going to the party, and it's true that my friend's going to the party. So me and my friend are going to the party. That's true. Okay. So this would be the statement: me and my friend are going to the party. All right. So here we're saying I'm going to the party, but my friend is not going to the party. So it's false that me and my friend are going to the party, right? Because it's just one of you. So here, I'm not going to the party, but your friend is going to the party. So it's a false statement that me and my friend are going to the party, right? That's not true. It's a false statement because you're both not going. So I'm not going to the party, my friend's not going to the party, so it's false that me and my friend are going to the party. Okay? So you see how that works? Okay. All right, so let's try. Okay, here we're saying let P represent 4 is greater than 1, and Q represents a statement 12 is less than 9. Find the value for P and Q. Yeah, that's right. And I'll show you how to do that on paper so that it's to work with. So we're said before, let me get my slide here so I can. So one way you can look at this, write it down, is you can say P is 4 is greater than 1, Q, this without the line, Q is 12 is less than 9. So we want to know P and Q, okay? So it's true that 4 is greater than 1, right? So we put a true there. But it's false that 12 is less than 9. 12 is greater than 9, right? So that's a false statement. So we're saying true and false is false, okay? So the only time P and Q are true is when they're both true, okay? When you and your friend are going to the party, okay? Questions with that? All right. So that's a false statement. Okay, so the next one, truth tables involving or symbolize one or the other, either one. Okay, so if we're talking about you and your friend going to the party again, this time we're saying either I'm going to the party or my friend's going to the party, but we don't both have to be going to the party. So one or the other. So here we're saying I'm going to go to the party and my friend's going to go to the party, so I or my friend are true. We're going to the party, one or the other. I'm going to the party. My friend is not going to the party, but since it's one or the other, it's true. Me or my friend are going to the party. That's a true statement. Here, I'm not going to the party, but my friend is, so me or my friend is true, are going to the party. I'm not going to the party, my friend's not going to the party, so me or my friend, that's a false, because neither one of us are going. Okay? Questions with that? Okay, so I'll let you write that down. So you want to put or on there for one or the other. Questions there. All right. So we're looking at the same two things again, right? This time we're saying P is 4 is greater than 1. Q is 12 is less than 9. Again, we're saying 4 is, and then now we're saying P or Q, right? Yeah. Okay, so we're saying 4 is greater than 1, that's true. 12 is less than 9, that's false. But now we're saying P or Q. That's true, right? Because 4 is greater than 1 or 12 is less than 9. That is true. Okay, you only need one or the other to be true. Questions there? Okay. Okay, truth tables. This should be tilde symbol here. Let me go ahead and put that. You can put that in there. So we have P. That should be where that box is. It should be not P. And let's see. You probably have that. Yeah, P and not P. Okay. So when P is true, not P, is false. It's the negation. And so when P is false, then not P is true. So this would be equivalent to I'm going to the party. The negation would be I'm not going to the party. Or I'm not going to the party. The negation to that would be I am going to the party. Questions? All right. Okay, so let's look at the next slide. Okay, here we are. Okay, here we have P, again, is 4 is greater than 1. Q is 12 is less than 9. And R, 0 is less than 1. Okay, so, and we're going to look at not P and not Q to start with. Okay, so we're saying here that 4 is greater than 1, that's still true. 12 is less than 9, that's still false. And 0 is less than 1, that's true. Well, we're only looking at P and Q. So, since P is true, then not P is false. Okay? If P is true, then not P is false. If Q is false, then not Q is true. Good. So true or false and true would be true or false? False, because they both have to be true in order for and to be true. Okay? So that one's false. All right. So, all right. So now we're going to look at P. P again. Q, R. And that's still 4 is less than 1. 12 is, or 4 is greater than 1 rather. 12 is less than 9. 0 is less than 1. And we're still saying that this is true. 4 is greater than 1 is true. 12 is less than 9 is still false. 0 is less than 1. Is that true or false? 0 less than 1. Is that true or false? True. Okay, so now we're looking at the truth table. Not P and R, or not Q and P. Okay? So we want to draw columns for each one of these. All right. So if P is true, then not P is false. All right, good. Now you want to go slow with this because it kind of shifts gears on you, and you want to kind of take it easy. So R is true, so that's going to be true there. So false and true would be
False. Good, because they both have to be true. Okay, now here, if Q is false, then not Q is true. Good. And P, we already said that's true, right? And that's what I was talking about. Be careful, because it'll shift gears on you. This is exactly what I'm talking about. Here we were talking about not Q, right? It's the opposite. But here we didn't say not P. This is P. So this one's the opposite, but this one is not. So that's why I was telling you got to be really careful. Take a second to think about what's going on. Okay, so now true and true would be true. Good. Okay, so now so you do the parentheses first, just like in the order of operations. Do the parentheses on one, do the parentheses on the other, and then you look at the conjunction of one and the conjunction of the other to get this one. So this is your final answer here. So we're saying false, but is this what? Or and? Or. False or true is true. Good. Okay, and that's your answer. That's your answer right there. Okay. So the homework won't have a truth table like this. You'll have to construct your own, and I recommend that you construct it on a separate piece of paper. Okay. What you'll see on the homework is something more like where's one of those? Oh, what they'll show you on the homework is they'll tell you P represents 7 is less than 8, Q represents 2 is less than 5, less than 6, and R represents 3 is less than 2. And then, so you'd have to construct your own truth tables from that, okay? But it's the same process as what we've been doing right here, okay? All right, questions with that? Okay. Oh, go back. Yeah, sure. Here it is.